Hello, pre-calculus students. Today we're going to start our study of trigonometry. Now, some people, trigonometry is one of those really scary, oh my God, words. It's really long, it's ancient Greek. Trigonometry means three-angle measure. It's the study of triangles. Triangles aren't that tough, right? You've been doing triangles since you were a kid. So let's start doing some adult work with triangles. We're going to start with right triangles. And if this is my angle, this is the right angle, so we only have to worry about the other two. If I'm looking at this angle, I'm going to call it angle theta. Theta is a Greek letter. We're going to make it by drawing a circle with a diameter through it. That's the Greek letter theta. It made the th sound. So if this is the angle theta, then we have terms for each of the three sides of the triangle. The side opposite angle theta is opposite. I know, right? The side adjacent to angle theta is the adjacent side. Then the hypotenuse is always the longest side of the right triangle. So we have some trig ratios that we can come up with. Cosine of theta, often written COS. Do not call it cos or cos to me. It's a cosine. You can use two syllables. It's okay. So cosine of theta is adjacent over hypotenuse. The sine of theta is opposite over hypotenuse. And the tangent of theta is opposite over adjacent. Since the hypotenuse is the longest side of the right triangle, obviously cosine and sine can never be greater than 1 on a right triangle. But this side could be 4 times as long as this side, so a tangent can be greater than 1. We all know that 3, 4, 5 triangle is a right triangle. So if I've let this angle be angle theta, then the cosine of theta is adjacent over hypotenuse, 4/5. The sine of theta is opposite over hypotenuse, 3/5. And the tangent of theta is opposite over adjacent, 3/4. There are also 3 other trig ratios that are just the reciprocals of these. So the reciprocal of cosine is secant. So the secant of this angle would be 5/4. The reciprocal of sine is cosecant, and because COS is cosine, cosecant is CSC. And the reciprocal of tangent is cotangent. Now I know if you're like me, you think, why is cosine and cosecant not a pair? I mean, tangent and cotangent are a pair. You know, sine and here's how I remember it. There's one co in each of these reciprocal pairs. Cosine, secant. Sine, cosecant. Tangent, cotangent. That's how I remember it. Now, back in probably middle school, you learned about some special right triangles, the 30, 60, 90, and the 45, 45, 90. Now, your 30, 60, 90, your 30-degree angle is pi over 6 radians, or pi over 6. This angle, the right angle, is pi over 2. And you might remember the mnemonic short side equals half the hypotenuse, SSHH. So if I make my hypotenuse 2, this is the short side is 1, and the short side has to be opposite the 30-degree angle. And 2 minus 1, I'm sorry, 4 minus 1 is 3, so this side has to be square root of 3. So based on these 30, 60, 90 triangles, no matter how long each of the sides are, the cosine of this will be adjacent over hypotenuse, root 3 over 2. The sine is opposite over hypotenuse, 1/2. And the tangent of 30 degrees would be opposite over adjacent, 1 over root 3. And when we rationalize the denominator, it's root 3 over 3. Now, if I had to let this be my angle, then I'd draw it this way to make it a little clearer. 60 degrees is pi over 3 radians. Cosine of 60 is adjacent over hypotenuse, 1/2. Sine of 60 is opposite over hypotenuse, root 3 over 2. And the tangent of 60 degrees is root 3 over 1 or root 3. In a 45, 45, 90 right triangle, you know, if this is 1, this is 1, this is going to be the square root of 2. So a 45-degree angle is pi over 4 radians. So the cosine of 45 degrees, or the cosine of pi over 4, is adjacent over hypotenuse, 1 over root 2, which we write this way. Sine of 45 degrees, or sine of pi over 4, is also, well, it's opposite over hypotenuse. It's also 1 over root 2, or this way. And tangent of 45 degrees is 1. Now I'm going to show you the most important theorem in all of trigonometry. So let's start with our triangle, our right triangle. If this is the angle theta that I'm looking at, then this side will be adjacent, this side will be opposite, and this side will be hypotenuse. Well, we know that from the Pythagorean theorem that this side squared plus this side squared equals this side squared. Well, let's divide everything by this side squared. I mean, it's just a length, right? Divide both sides of the equal sign by hypotenuse squared. And look what you get. What is adjacent over hypotenuse? What is that trig ratio? If you said cosine of theta, that's correct. So this would be adjacent over hypotenuse times adjacent over hypotenuse. Cosine times cosine is cosine squared of theta. We don't write cosine theta squared because we're not squaring the angle theta. You could put parentheses around cosine theta and square it, but to save on the writing, we just write cosine squared to point out that it's the cosine, the ratio, that's being squared, not the angle. Now here we have opposite over hypotenuse. That's sine theta. So we square those, we're squaring sine theta, and this is 1. So this is the most important identity in all of trigonometry. Cosine theta squared plus sine theta squared equals 1. Or if you want to say it the way you read it, most people read it as cosine squared theta plus sine squared theta equals 1. Now, I have this belief that if something is stupid and it works, then it's not stupid. But I don't know why anybody would want to memorize this. You've probably all seen it and heard it before. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. That's what it means. But SOHCAHTOA doesn't mean anything. You're memorizing sounds. You're like that guy who worked with Java. You know, R2, or when C3PO was talking to him, and I think it was Empire Strikes Back. R2 de Toa, C3P Oa. That's seriously, that's what I hear. I don't know why you just don't memorize one of them and the others fall into place. Because this is, I mean, it's not like, please excuse my dear Aunt Sally. At least that means something. And the letters will give you the order of operations. Unless you come up with something that this could mean, you're just making sounds. And to me, that's just something else to memorize. But if that works for you, okay. So that is the first part of right triangle trigonometry. We've learned the three primary trig ratios, sine, cosine, and tangent. And I introduced to you the three reciprocal functions, cosecant, secant, and cotangent. Now let's see what it means to solve a triangle. When we solve a triangle, we're finding the lengths of all three sides and the measures of all three angles. Come on, that can't be tough, right? The triangles are easy. So because I'm a good American, if 50 feet away from the flagpole, the shadow is casting the shadow is 50 feet long, and I'm measuring up to the top of the flagpole, or if I'm just 50 feet away from the flagpole and the angle measuring up to it is 37 degrees, how tall is the flagpole? Well, we can use some right triangle trigonometry. What trig ratio relates this angle to these two sides? Well, if you said it was the tangent, you're correct, because tangent of an angle is opposite over adjacent. So if we look, the opposite is y, the adjacent is 50, and the angle is 37 degrees. So the tangent of the angle is opposite over adjacent. Multiply both sides by 50, and we'd get that the flagpole is 37.7 feet tall. Something that's very, very important. Muy importante. When I turn on my computer, or my calculator, I'll zoom in for you. Notice it says degrees down here in the lower right-hand corner. That's great because this angle is 37 degrees. If we were measuring it in radians, I hit this DRG button. This is degrees, radians, and grads. Don't worry about grads. I don't think anybody uses grads anywhere in the world anymore. Now I'm in radian mode. So that the degree in radian and grad mode only matters when you're doing, there's grads, when you're doing trig functions. I mean, I can add and subtract, multiply all day, and that doesn't matter. But when I'm taking a trig function, a sine, a cosine, or a tangent, or one of their reciprocals, I have to be in the correct mode. So I want 50 times the tangent of 37 degrees. Yep, I'm in degree mode. 50 times tangent of 37. Now it knows its degrees because it says so down here, and that's where the 37.7 comes from. Your calculator may be different. If you have a Casio, maybe it's different. If you have an older Texas Instruments, maybe it's different. Sometimes you have to put the 37 in first, then take the tangent. So you do 30, and to key it in, it would be 37 tangent, and that would give you this number. That's the trig ratio. And then you'd multiply that by 50. You need to know how your calculator works. If it's going to do all the work for you, the least I can expect of you is to know how to use it properly. All righty, so let's take a look at this practice problem. Go ahead and pause your screen, copy this down, and what we're going to do is based on this, we're going to solve the triangle, which means I've got two sides and an angle already done. So I need to know what this third side is, and I need to know what these two angles are. You can see it's a right triangle, so we'll be able to use our trig ratios. We'll do that in class. So I guess that's enough for this lesson. Yeah, it's good enough. Have a great day.